Today in class we will find the point where the graph of the function intersects the coordinate axis. To do this, we need to recall the rule. Let's write down the equation of the line. It looks like this. 5x minus 2y plus 6 equals 0. We need to find the coordinates of the point where the graph of this function intersects the axis x and the axis y. Therefore, I will write it down. The intersection sign of the graph of this function with the x-axis. Let's recall. To find the coordinate of the point where the graph of this function intersects the x-axis, without constructing it, we need to substitute 0 for y. This rule is easy to remember. We have only two axes, the x-axis and the y-axis. When you find the coordinate of the point where the graph of the function intersects the x-axis, then the y-coordinate is 0. In this case, I will substitute the value of y equal to 0 into our equation. As a result, we will get 5x minus 2 times 0 plus 6 equals 0. And we have obtained an equation with one variable. In this case, 5x minus 0 plus 6 equals 0. And obviously 5x equals negative 6 and x equals negative 6/5, or negative 1 and 1/5. Now we need to write down the coordinate of this point. To record the coordinate of this point, we must write down a pair of values. In the first position, we have the value of x, and in the second position, the value of y. If we found the value of x, which is equal to minus 1 and 1/5, and we have recorded the value as 0, then the point with the coordinates negative 1.2 and 0 will be the point where the graph of our function intersects the y-axis. Using this algorithm, we will find the coordinates of the point where the graph of this function intersects the y-axis. And then it is obvious that if we are looking for the intersection with the y-axis, then x is equal to 0. And in our equation, we will substitute 0 for x. The value of y we will find. We see that 5 times 0 is 0, minus 2y plus 6 equals 0. Then minus 2y equals minus 6, and y equals 3. Now let's record the intersection point of our linear functions graph with the y-axis. If we set the value of x to 0, then I write the coordinate as 0, and for y, it equals 3. We solved this problem and found the coordinates of the point where the graph of our function intersects the y-axis, which is equal to negative 1.50, and the coordinates of the point where the graph of the function intersects the y-axis. And this point has coordinates 0, 3. As you can see, if we were plotting the graph of this function, it would be easy to determine the intersection point with the y-axis. But with the x-axis, we would need to find the value of the x-coordinate. Therefore, when finding the points of intersection without using a graph, use the algorithm. In one case, y equals 0, and in the other case, x equals 0. In the next lesson, we will solve a task related to the graph of a linear function. But for today, our lesson has come to an end. Goodbye. See you next time.